Tonight, we are going to dismantle a picture that has been sitting quietly in the back of your mind since you were a child. A picture so simple, so familiar, so often drawn on the chalkboards of elementary classrooms that you have probably never thought to question it. It is the picture of the Earth as a neat round ball with an arrow pointing up toward something labeled sky and another arrow pointing down toward something labeled core. Above, a few cheerful clouds. Below, a glowing red center. And in between, you, standing on the surface, looking up. Looking down, comforted by the certainty that you know, more or less, what is above your head and what is beneath your feet. That picture is wrong, not just incomplete, not just simplified. Wrong in ways that, by the end of this night, will leave you looking at the ceiling above your bed and the floor beneath it and feeling a quiet, dizzying vertigo. Because what sits directly above you, right now, in the air over your head, is not a single thing. It is a stacked tower of invisible layers, each one stranger than the last, each one ending in a frontier that humans only crossed within living memory. And what sits directly below you, beneath the soles of your feet, is not simply rock and fire. It is a layered descent through worlds we have never seen, into a heart that only a few years ago scientists discovered was hiding a secret inside itself. A heart within a heart, a core within a core. Spinning, slowing, reversing, and beating to a rhythm we are only just beginning to hear. So here is the question we will spend the next 2 hours circling, the question that may, if you let it, keep you up tonight. If you stood perfectly still right where you are, and drew one line straight up from the top of your head and another straight down through the floor, and you followed those two lines outward in both directions. Not for a few meters, not for a few miles, but as far as they would go, what exactly would you pass through? What worlds, what voids, what oceans of fire, what oceans of darkness? And how far do those lines actually reach before they end, or before they stop meaning anything at all? The answer is larger, and stranger, and quieter, and more humbling than almost anyone ever stops to imagine. We are going to climb that line upward together layer by layer from the air, just above your scalp through the boundary where sky becomes space. Past the satellites and the moon and the sun, past the edge of our solar system into the dark between stars and outward still, until the very idea of upward begins to lose its shape. And then we are going to do something even stranger. We are going to turn around, and we are going to descend that same line in the opposite direction. Down through the crust, down through the mantle, down through the molten outer core, down to the spinning iron heart at the center of the earth. And then, impossibly, we are going to keep going. Because if you keep falling through the center of the earth, you do not stop. You come out the other side. And what waits on the other side is, almost certainly, an empty stretch of ocean you have never seen, with the same sky above it and the same depths beneath it, mirroring your own. Before we go any further, if you find this kind of slow, deep exploration of the universe fascinating, a quick like, or a soft tap of the subscribe button really does help this channel grow. It is a small thing for you, but it makes an enormous difference for me, and for the work that goes into building these long, quiet journeys. That is the only time I will ask. Now, let us begin properly. Picture yourself standing somewhere familiar, perhaps in your bedroom, perhaps in your garden, perhaps in the place where you are listening to this voice right now. The ground beneath your feet feels solid. The air around your face feels empty. The sky above seems to begin somewhere just past the rooftops and to end somewhere far beyond the clouds. This is the comfortable, tidy mental map almost every human being carries. A floor, a ceiling, a self suspended between them. And yet, in truth, you are not standing on a floor at all. You are clinging to the outer skin of an enormous spinning layered sphere, tumbling through a vacuum with thousands of kilometers of rock and metal beneath you and hundreds of kilometers of increasingly thin gas above you, and beyond that gas, a darkness so vast and so deep that the word above stops being a direction, and starts being a confession of how small we really are. Have you ever stopped to ask yourself, honestly, what you actually believe is directly above your head right now and directly below your feet? Not the textbook answer, not the answer you would write on a test. The picture, the actual picture that flickers in your imagination when you close your eyes and try to see it. Is it a thin blue dome, the way you drew it as a child? Is it a cartoon cross-section of the earth with neat colored bands? Hold on to that image, whatever it is, because we are going to take it apart, gently, layer by layer, starting with the very first layer pressing softly against your skin at this exact moment. The layer of air. The one you cannot see. The one you have been breathing your entire life, without ever truly knowing where it ends, where it changes, where it dies away into something that is no longer air at all. That boundary, the place where our familiar sky finally lets go of us, is closer than you think, and the journey to reach it begins with the very next breath you take. The breath you just took, the one moving through your nose and into your lungs, came from a layer of the earth so thin that, if our planet were the size of an apple, this entire layer would be thinner than the apple's skin. It is called the troposphere, from a Greek word meaning to turn, to mix, to churn. And that name is no accident, because this is the restless layer, the boiling layer. The layer in which every storm you have ever sheltered from, every cloud you have ever watched drift across a summer sky, every snowflake, every raindrop, every gust of wind, every breath of every living thing on earth has happened. All of it. The entire theater of human weather, the entire stage on which life performs, packed into a layer roughly 10 to 12 kilometers thick at the equator, and only 7 or 8 kilometers thick near the poles. If you could somehow drive a car straight upward at highway speed, you would punch through the top of the troposphere in about 6 minutes. 6 minutes. That is the entire thickness of the world you have ever known. And yet within those few kilometers, almost everything you associate with the word sky is folded. The clouds, the birds, the airliners cruising at their familiar altitude, the Himalayan summits scratching at the upper edge. Mount Everest, at just over 8.5 kilometers, pokes its bare peak nearly out of the troposphere entirely, into a zone where the air is so thin that a human being, unaided, begins to die within minutes. Climbers call the region above 8,000 meters the death zone, and they are not being poetic. It is a place where your body cannot acclimatize, where every additional hour spent breathing is a slow, measured surrender. And it sits, on a clear day, only a vertical hour or two above the place where you are listening to this voice. But the troposphere is only the first room in a much taller house. As you continue upward, the air grows colder and thinner and colder still, until you reach a strange invisible ceiling called the tropopause, somewhere around 12 kilometers above sea level. And here, something curious happens. The temperature, which has been falling steadily as you climbed, suddenly stops falling. It levels off, and then gently, against every expectation, it begins to rise again. You have crossed into the second layer, the stratosphere, the layer from which our planet quietly defends itself against the sun. The stratosphere is calm. It is layered, stacked, stable, with very little vertical mixing, which is why long-haul airliners love the lower edge of it. When you fly from one continent to another, you are gliding through the bottom floor of the stratosphere, looking down at the troposphere's weather, often watching thunderstorms churn far below you while your own window remains perfectly clear. It is also the layer that holds the ozone shield, a delicate, invisible canopy of 3-atom oxygen molecules, soaring somewhere between 20 and 30 kilometers above your head, absorbing the ultraviolet radiation that would otherwise sterilize the surface of the Earth. Without that thin, fragile layer of ozone, life as we know it could not exist on land. And it is so easy, so dangerously easy to forget that it is there. Higher still, beyond the ozone, somewhere around 50 kilometers up, the temperature begins to fall again, and you cross another invisible ceiling, the stratopause, into a layer almost no human has ever directly visited, the mesosphere. The middle sky. This is the strangest of the lower layers, too high for airplanes, too low for satellites. A kind of forgotten kingdom, hanging in the dark between worlds, where the air is so thin that wings have nothing to grip, and yet thick enough to set incoming meteors on fire. Every shooting star you have ever seen, every flash of light that has streaked across a clear night sky and made you gasp, has burned, almost without exception, in the mesosphere. Those grains of cosmic dust, some no larger than a sand grain, hit this layer at tens of kilometers per second, compress the thin gas in front of them, and ignite into the brief, beautiful streaks we call meteors. The mesosphere is, in a very real sense, the Earth's outer fence, its first line of defense against the small debris of space. Within the mesosphere, at its very top, around 80 kilometers up, you may also find the rarest, most ghostly clouds on Earth, noctilucent clouds, night-shining clouds. Wisps of ice crystals so high above the surface that, long after the sun has set on the people below, they continue to glow with a silvery blue light, as if the sky itself were remembering the day. They are seen mostly in summer, at high latitudes, by patient observers who know to look upward in the deep twilight, and they are appearing more often now in places they were never seen before, a quiet sign that even this hidden layer is changing. Climb higher. Past the mesopause, the coldest natural place in the entire atmosphere, where temperatures can drop below minus 100 degrees Celsius, and you enter the thermosphere. Here, against all instinct, the temperature begins to soar. Not because there is more heat, but because the few remaining atoms are being struck so violently by the radiation of the sun that each one carries an enormous amount of energy. The thermosphere can reach temperatures of 2,000 degrees Celsius, and yet, paradoxically, you would not feel hot inside it, because the gas is so thin that there are simply too few particles to transfer that heat to your body. It is a layer where the very meaning of temperature begins to slip, and it is in the thermosphere, somewhere between 80 and 600 kilometers above your head, that the aurora is born. Those rivers of green and pink and violet that pour across the polar skies are not happening near the ground. They are happening high above the airliners, high above the weather, high above the ozone, in this thin, almost empty layer, where particles flung from the sun spiral down along the Earth's magnetic field lines, crash into atoms of oxygen and nitrogen, and force them to release their energy as colored light. When you look at an aurora, you are looking at the sun's breath, painted onto the inside of the Earth's invisible shield. And finally, above the thermosphere, you reach the exosphere, the last, faintest whisper of atmosphere, stretching from a few hundred kilometers up to as much as 10,000 kilometers above the surface, depending on how generously you define its edge. In the exosphere, the air is so thin that individual molecules can travel for hundreds of kilometers without ever colliding with another one. Hydrogen atoms drift here, helium atoms drift here, and many of them, over the long, slow centuries, drift outward and leak away into space entirely. The Earth, in this sense, is gently breathing itself away, atom by atom, into the cosmos, a planet that is, very slowly, exhaling. It is staggering when you stop to consider it that all of this, every layer, every kingdom of gas, the storms and the ozone and the meteors and the auroras and the ghostly noctilucent clouds and the leaking hydrogen, all of it is happening directly vertically above your head right now while you breathe quietly in the dark. The sky is not one thing. It is a stacked architecture, a cathedral with many ceilings, and humans slowly, painfully, have climbed those ceilings one by one. The earliest hot air balloons in the late 1700s lifted curious souls a few kilometers into the lower troposphere, where they discovered, to their astonishment, that the air grew colder and thinner the higher they rose. By the early 20th century, balloonists in pressurized capsules were pushing into the stratosphere, looking down at the curve of the Earth for the first time. In the 1960s, an American military pilot named Joseph Kittinger rode a high-altitude balloon to 31 kilometers and stepped out, falling for over 4 minutes through the silent stratosphere before his parachute opened. And in 2012, an Austrian skydiver named Felix Baumgartner climbed even higher, to nearly 39 kilometers, and jumped, becoming, for a brief few seconds, a human being moving faster than the speed of sound through the upper stratosphere, with nothing above him but a thinning sky. 2 years later, a Google executive named Alan Eustace quietly pushed that record slightly higher still, to just over 41 kilometers. And yet, even at those altitudes, those balloonists, those jumpers, those record holders were still well below the top of the stratosphere. Still in the second room of a much taller house. Still, in a sense, barely off the floor. The fastest aircraft ever flown by a human pilot, the SR-71 Blackbird, a long, dark, beautiful machine designed for reconnaissance during the Cold War, cruised at around 25 kilometers up, sliding through the lower stratosphere at 3 times the speed of sound, leaving the weather far below it. Weather balloons routinely climb to 30 or 40 kilometers and burst. Specialized research balloons reach the mesosphere only briefly, before their instruments fail in the cold and the thinness. And above that, almost nothing flies in any conventional sense. The mesosphere, that strange middle kingdom, remains one of the least studied regions of the entire planet's vertical structure. We have walked on the moon, 400,000 kilometers away, before we have ever properly explored the air 80 kilometers above our own heads. Let that sit with you for a moment. Above your head, right now, there is a region of the Earth's own atmosphere that we, as a species, have visited less often than we have visited the lunar surface. A layer where shooting stars burn, where ghostly clouds glow long after sunset, where the air is too thin to breathe, too thick to orbit, and too cold to easily measure. A layer that sits, vertically, between you and the rest of the universe. So I want to ask you something gently before we climb higher. What is the highest you have ever been above the surface of the Earth? Was it a mountain you hiked, a balloon you rode, an airliner cruising over an ocean? And when you were there in that moment, did it occur to you that you were still, in cosmic terms, almost touching the ground? Did you ever feel that strange, quiet vertigo of realizing that, no matter how high you have climbed in your life, you have probably never even left the bottom 2 layers of the sky? I would love to know your highest moment, your highest memory, the highest you have ever felt the wind. Let that thought stay with you for a while, because what comes next is something no commercial flight has ever reached. No mountain rises into it. No balloon, no skydiver, no SR-71. To enter the next layer, you have to leave the atmosphere altogether. You have to cross a boundary that scientists, somewhat arbitrarily, have agreed to call the edge of space. It is a line in the sky that has no physical wall, no door, no marking. And yet on one side of it you are still, technically, in the air of your home planet. And on the other side, you are an astronaut. That line sits 100 kilometers above your head, and it is where we are going next. 100 kilometers. That is the number we have agreed upon. A neat, round, human number, drawn through the sky like a chalk line on a vast, invisible blackboard. Above it you are in space. Below it you are in the atmosphere. And yet, if you were actually there, riding upward in some impossible elevator, you would notice no sudden change. No curtain to part, no threshold to cross. The air would simply continue to thin, the sky would simply continue to darken, the stars would simply continue to sharpen against an ever blacker background. There is no wall at 100 kilometers. There is only an agreement. It is called the Kármán line, named after Theodor von Kármán. a Hungarian-American engineer who in the middle of the 20th century did the calculations and proposed that somewhere around this altitude the air would become so thin that an aircraft, in order to generate enough lift to stay aloft, would have to travel faster than orbital velocity. In other words, above this line, you cannot fly in the traditional sense any longer. The atmosphere has effectively given up on supporting you. The only way to remain up here is to fall, sideways around the Earth, fast enough that you keep missing the ground. And that, in the simplest possible language, is what an orbit is. Not staying up, falling forever while going sideways quickly enough to never quite arrive. The Kármán line is, in truth, somewhat arbitrary. Different agencies define it differently. The United States Air Force, for many decades, awarded astronaut wings to pilots who crossed 80 kilometers, considerably lower. The international standard, set by the Fédération Aéronautique Internationale, places it at 100. Some atmospheric scientists argue with good evidence that the true functional boundary lies somewhere closer to 80 kilometers, where the chemistry and behavior of the upper air begins to change in fundamental ways. But for most of us, for the cultural imagination at least, 100 is the number. The line above which the word astronaut applies and below which it does not. What is remarkable is how thin a margin this is. 100 kilometers in human terms is not a long way. If you could lay the Kármán line flat on the ground and drive along it, you could cross it in under an hour at modest highway speeds. The distance from London to Brighton, the distance from Tokyo to Mount Fuji, the distance from New York City to Philadelphia is, in each case, longer than the distance from your feet to the edge of space. And yet that vertical sliver is the only thing standing between you and the airless dark. Picture that for a moment. The entire breathable, livable, weather-bearing skin of your home planet is, in cross-section, thinner than the morning commute of millions of strangers. But what waits just above that line is far stranger than the simple word space suggests, because space, just above the Kármán line, is not yet empty. Not really. The exosphere, that last whispering remnant of atmosphere, still extends outward for thousands of kilometers, growing fainter and fainter, until at last there are simply not enough atoms to call it a gas at all. And folded within that fading veil, surrounding the Earth like nested invisible shells, are some of the strangest, most powerful, most dangerous structures in the entire neighborhood of our planet. They are called the Van Allen radiation belts. And they were not discovered until the late 1950s, when the very first American satellite, Explorer 1, carried a small Geiger counter into orbit and started screaming. The Van Allen belts are vast, donut-shaped regions of charged particles, trapped by the Earth's magnetic field, swirling endlessly around our planet. There are two main belts, an inner one beginning a few hundred kilometers above the equator and stretching outward to around 6,000 kilometers, and an outer one extending from roughly 13,000 to 60,000 kilometers up. Within them, protons and electrons, flung outward from the sun and trapped by our magnetic field, race along invisible field lines at significant fractions of the speed of light. To an unshielded human being, the inner belt is lethal. Apollo astronauts on their way to the moon deliberately threaded a trajectory that crossed the belts as quickly as possible, at angles designed to minimize their exposure. Even so, those few crossings remain the most heavily irradiated moments any human being has ever endured. The Van Allen belts are, in a very real sense, an invisible moat around our planet, a defensive barrier of trapped radiation. Without them, much of the solar wind would strike our atmosphere directly. With them, most of it is gently deflected or held in temporary storage before slowly leaking away. Surrounding all of this, holding it in shape, is something even more astonishing: the magnetosphere, the magnetic shield of the Earth. Generated, as we shall see when we descend, By the spinning iron heart of our planet, this invisible shield extends outward into space in a teardrop shape. On the side facing the sun, it is compressed by the solar wind to a distance of about 65,000 kilometers above the surface. On the side facing away from the sun, it streams outward in a vast magnetic tail, a magnetotail stretching for hundreds of thousands of kilometers, possibly past the orbit of the moon. You are living, at this very moment, inside a magnetic bubble that is larger than many of the structures you can see in the night sky. And without it, our planet would be a very different, far less hospitable place. Within this great bubble, in the thin slice of space between roughly 100 and 600 kilometers above the surface, lies the region we call low Earth orbit. And it is here that humanity, in the last 60-odd years, has built our first cautious outpost in the sky. The International Space Station orbits at roughly 400 kilometers up, circling the Earth once every 90 minutes, traveling at about 28,000 kilometers per hour. If you have ever stepped outside on a clear evening, just after sunset or just before dawn, and looked up to see a single, very bright, unblinking dot moving steadily across the sky, faster than any airplane, you have probably seen it. That little moving point is a habitat the size of a football field, with humans inside it, watching 16 sunrises and 16 sunsets every single day, looking down at the curve of the Earth, looking out at the black of space, and looking back at us. Right now, as you listen, there are people up there. There have been people up there continuously since the year 2000, for more than 2.5 decades without interruption. The longest continuous human presence in space in our history, but low Earth orbit is no longer empty. Not by a long stretch. As of late 2025, more than 10,000 active satellites circle the Earth, and the number is growing every month. The vast majority of them belong to a single constellation, SpaceX's Starlink network, which has placed thousands of small communication satellites in low orbits, with thousands more planned. Other constellations are launching to compete. Astronomers who have spent their entire lives looking up at the stars are now watching their long exposures of the night sky streak again and again with the bright trails of passing spacecraft, and a quiet debate has begun about what the night sky of the next generation will even look like. Will future children looking up at the stars see more moving lights than fixed ones? Will the constellations be visible at all beneath the bright haze of our own technology? And there is debris, so much debris. Old rocket stages, dead satellites, fragments from collisions, paint flecks, frozen droplets of coolant, all of it whipping around the Earth at orbital speeds, where even a 1-centimeter object carries more kinetic energy than a hand grenade. Tracking networks watch more than 30,000 objects larger than 10 centimeters, and estimate that hundreds of thousands of smaller pieces also race silently around our planet, in a slow, dangerous shell of our own making, the shell of human leftovers. The first ring of Saturn we have ever built around ourselves, except ours is made not of ice, but of garbage. Climb further. Past low Earth orbit, past the brightest layer of human activity, and you enter a quieter realm. The medium Earth orbits, where navigation satellites live, the constellation of GPS satellites that, at this very moment, are quietly pinging your location to your phone from roughly 20,000 kilometers above your head. Without them, modern life as we know it does not function. Without them, ships lose their headings, aircraft lose their precise routes, financial transactions lose their timestamps, and a generation that has forgotten how to read a paper map finds itself, suddenly, lost in its own city. And yet how often in the course of a normal day do you stop and think about the 30 or so small machines, drifting 20,000 kilometers above your head, that are quietly telling you where you are? Keep climbing. Push further outward, and at roughly 35,786 kilometers above the equator, you arrive at an extraordinary altitude, geostationary orbit. At this exact distance, an object completes one full orbit of the Earth in exactly 24 hours, which means it appears from the ground to hang motionless in the sky, always above the same point on the equator. This is where television satellites live. This is where many weather satellites live. And there is something almost poetic about the idea of a machine the size of a small bus, suspended in the same spot in the sky year after year, decade after decade, looking down at the same continent, watching the same storms drift across the same coastlines while the Earth beneath it spins. From a geostationary satellite's perspective, the Earth never sets. It is simply always there, hanging in the same window, slowly turning beneath you like a great blue marble that refuses to ever leave the room. To put 35,786 kilometers in context, this altitude is nearly 3 times the diameter of the Earth itself. If you shrank our planet down to the size of a basketball, geostationary orbit would be a thin ring of satellites circling at about 70 centimeters away. The International Space Station, by comparison, would be hugging the surface at less than a centimeter. The Moon, which we will reach in time, would be a tennis ball at almost 7 meters distance. So you see, even what we casually call space is itself layered. The crowded near shell of low Earth orbit, the quieter mid-orbits, and the distant ring of geostationary watchers far above them all, looking down on a slowly turning home. So here is something I want you to consider before we leave near-Earth space behind. Have you ever, on a clear evening, stood outside and watched the International Space Station pass overhead? That tiny, fast-moving, unblinking dot, brighter than any star. If you have, do you remember the feeling, that strange catch of breath, when you realized that the small light moving across your sky was a building, with humans inside, looking down at the very ground you were standing on? And if you haven't, would you try, sometime soon, to step outside on a quiet night and wait for it? There is a particular kind of quiet wonder in seeing it for the first time. A reminder that the sky directly above your head is not just air, not just clouds, not just stars, but also, right now, occupied, inhabited, crossed in this very moment by other human beings, falling forever around the same planet that holds you up. I would love to know if you have ever seen it, and what you felt when you did. But even the International Space Station, even the geostationary watchers, even the entire cloud of human satellites taken together, are not yet truly far from home. We have only climbed 36,000 kilometers. The Earth is still enormous beneath us. Our journey upward has barely begun. Because directly above us, hanging in the dark, slowly drifting outward year by year, sits an object so familiar that you have looked at it 10,000 times without ever truly understanding how far away it is. And we are about to leave the last shell of our own making and travel toward it, into the quiet space between Earth and Moon. Beyond the ring of geostationary satellites, the dark deepens. The familiar bustle of human activity falls away beneath you, and for the first time in our climb, you find yourself in a place that feels truly empty. No spacecraft hums in your vicinity. No bright bus-sized machine drifts past in formation. Just a long, slow, lonely stretch of vacuum, with the Earth shrinking behind you, and ahead, somewhere in the distance, a single pale companion waiting in the silence. The Moon. To reach her, you must travel, on average, 384,000 kilometers. That number, spoken plainly, does not sound especially dramatic. 384,000. A few zeros. The kind of figure you might glance at in a textbook and forget by the next page. But let it slow down. Let it stretch. If you could somehow drive a car straight up, at 100 kilometers per hour, without ever stopping, without ever sleeping, without ever pausing for fuel, it would take you more than 5 months of continuous driving to reach the Moon. 5 months. Of nothing but the road and the dark. And the Apollo astronauts, riding atop the most powerful rocket ever built by human hands, still took 3 full days to make the crossing. 3 days of falling in silence, through a space so empty that the only sounds inside the capsule were the breathing of the crew and the quiet ticking of instruments. To put the distance in another way, you could fit every single one of the other 7 planets of our solar system, lined up side by side, into the gap between the Earth and the Moon. Mercury, Venus, Mars, Jupiter, Saturn, Uranus, Neptune, all of them end to end, with a little room left to spare. The space between us and our nearest neighbor is, in planetary terms, an enormous chasm, and yet on a clear night the Moon looks so close, so bright, so available. As if you could reach up and touch her with your fingertips. That illusion of nearness is one of the oldest, most universal tricks our atmosphere plays on us. Within that vast stretch of cislunar space, the region between the Earth and the Moon, there are a handful of strange, invisible places that astronomers love. They are called Lagrange points, named after the 18th century French-Italian mathematician Joseph Louis Lagrange, who first calculated their existence on paper, more than a century before any human had ever left the ground. They are points in space where the gravitational pull of the Earth and the gravitational pull of the Sun, combined with the orbital motion of the system, itself balance in such a way that a small object placed there can remain more or less in the same position relative to both bodies. There are 5 of them in the Earth-Sun system, and we have begun, in recent decades, to use them as parking spaces. One of them, called L1, lies between the Earth and the Sun, about 1.5 million kilometers ahead of us, a quiet vantage point from which solar observatories like SOHO have watched our star uninterruptedly for decades. Another, called L2, lies in the opposite direction, 1.5 million kilometers behind the Earth, on the far side from the Sun. And it is there, in that cool, shaded, gravitationally calm pocket of space, that the James Webb Space Telescope has been quietly drifting since early in 2022, its enormous golden segmented eye turned outward toward the deepest, oldest light in the universe. Right now, as you listen, a telescope the size of a tennis court is parked 1.5 million kilometers above your head, opening time itself, looking at galaxies that formed when the cosmos was only a few 100 million years old. And it has been giving us, year after year, images so deep and so strange that we have begun, quietly, to rewrite parts of the story of how the universe grew. But cislunar space is mostly empty, almost cruelly so. A few small probes drift here and there. A handful of satellites have been parked in lunar orbits, including India's Chandrayaan-3 lander, which in 2023 placed a small rover near the lunar South Pole, the first spacecraft ever to do so. China's Chang program continues, with the Chang 6 mission, in 2024, returning the first ever samples from the far side of the Moon. Japan's SLIM lander touched down with surprising precision in early 2024. And NASA's Artemis program, with quiet international partnership, is preparing once more to send human beings, after more than 50 years of absence, back to the lunar surface. The first crewed Artemis mission to fly around the Moon is now expected in the coming year or two, and human boots are once again scheduled, tentatively, hopefully, to press into lunar dust before the end of this decade. After half a century of looking up at a moon we had abandoned, we are, at last, going back. And the Moon, that pale, patient companion, has waited. She has not gone anywhere. Or rather, she has been going somewhere very slowly the entire time. Because the Moon is drifting away from us. Each year she retreats by about 3.8 centimeters, the width of a small button, the length of a fingernail, almost nothing on a human timescale, but over hundreds of millions of years those small retreats accumulate. The Moon in the deep past was much closer to the Earth than she is today. In the era of the dinosaurs she was a touch nearer. In the time of the earliest single-celled life, several billion years ago, she was dramatically nearer. And in the very first 100 million years after she formed, born most likely from a colossal impact between the young Earth and a Mars-sized body called Theia, she may have hung in the sky barely 30,000 kilometers away, an enormous glowing, terrifying disk, dominating the heavens of a molten infant Earth. Today, she has wandered to her current distance, and she will, over the long arc of the future, continue to drift outward, slowly stealing the rotational energy of the Earth itself, slowing our days, lengthening our nights, retreating ever further into the dark. The moon herself is locked in an old and strange embrace with our planet. She rotates on her axis exactly as quickly as she orbits us, which means that the same hemisphere always faces the Earth. The near side, the one you have known your whole life. The face of the man in the moon, or the rabbit in the moon, or whatever your particular culture has named the shapes of the dark lunar plains. The other side, the far side, was hidden from human eyes for every generation that ever lived on this planet, until the year 1959, when a small Soviet probe, Luna 3, sent back the first grainy, ghostly photographs of a face no human had ever seen. The far side, when those images arrived, turned out to be strangely different, pockmarked, rougher, older, with far fewer of the dark volcanic plains that decorate the side we know. It was, in a sense, an alien hemisphere, hiding in plain sight, only a few 100,000 kilometers above our heads, for the entire history of human curiosity. When you look at the moon tonight, you are looking at the only world other than this one that human beings have ever touched. Between July of 1969 and December of 1972, 12 people walked on her surface. 12. That is all. Of the more than 100 billion human beings who have ever lived, only 12 have set foot on another world. And of those 12, fewer and fewer remain alive with each passing year. There will come a time, perhaps soon, when no living human being will remember from personal experience what it felt like to stand upon the surface of the moon and turn around and see the Earth, that small blue marble, hanging in the black sky. That memory will pass out of the species. And then, eventually, with Artemis, with the next generation, it will be reborn in new minds, in new boots, in new dust. The moon influences your life in ways you almost certainly do not feel directly, but cannot escape. The ocean tides, the great rhythmic breathing of the seas, are pulled into shape mostly by her gravity. Even the solid rock of the continents flexes, very slightly, twice a day, in response to her passage. Your body, full of water, experiences these tidal forces too, although their effect on you, individually, is essentially zero. The stories we tell, the calendars we keep, the festivals we still celebrate in the rhythm of waxing and waning light, all of them trace, somewhere in their origins, back to that single, slowly drifting companion. She has been the timekeeper of our species for as long as we have existed, and we have been her audience. So let me ask you gently, when was the last time you really looked at the moon, not glanced at her, not noticed her in passing, but stood still in the dark and watched her, and let your eyes adjust, and trace the dark plains and the bright highlands and the faint suggestion of craters across her face? And when you did you stop to think that you were looking at a place, a real, dusty, ancient place, hovering at that very moment, 384,000 kilometers above your head? Do you have a favorite phase of her? Are you a watcher of full moons, or of slim crescents, or of the strange gray ghost of a daylight moon hanging in a blue afternoon sky? I would love to hear what the moon means to you, in your own life, in your own memory. She has been there for every night of every person you have ever loved. But even the moon, far as she is, even 384,000 kilometers, is only the very beginning of the outward distance from your head. Beyond her, the gap widens dramatically. Because the next great body in our cosmic neighborhood, the one that anchors everything, the one whose gravity holds the Earth and the Moon and every planet in steady looping, orbits the one whose light gives you every shadow you have ever cast, sits not thousands of kilometers away. Not millions, but tens of millions of kilometers further still. The Sun. And the journey to her and through the kingdom she rules is where our climb begins to become truly cosmic. Beyond the Moon, the gap yawns open. Suddenly there is nothing for a very long time. No planet, no station, no orbiting watcher. Just darkness and a faint distant glow ahead, growing slowly brighter until at last, on the order of 150 million kilometers from where you stand, you arrive at the great furnace that anchors everything. The Sun. 150 million kilometers. Astronomers, in order to keep their arithmetic from collapsing under all the zeros, simply call this distance one astronomical unit, 1 AU, the natural yardstick of the solar system. Light, the fastest thing in the universe, takes 8 minutes and 20 seconds to cross that distance, which means that the sunlight currently warming the side of your face, the sunlight that is right now bouncing off the windows of your neighborhood and painting shadows on the walls of your room, left the surface of the sun more than 8 minutes ago. If the sun were to vanish somehow in this very instant, you would not know for another 8 1/3 minutes. The trees would still cast shadows. The sky would still be blue. The world would behave for that brief stretch exactly as if nothing had happened. And then all at once, the light would simply stop arriving. The darkness would fall like a closing eye, and only afterward would the cold begin. The sun is staggeringly large, so large that the word large stops being useful. You could fit more than 1 million Earths inside it and still have room to spare. Its diameter is 109 times that of our planet. If you shrank the sun down to the size of a basketball, the Earth on this scale would be a small green pea drifting roughly 30 meters away. The Moon would be a poppy seed nearly touching the pea. And everything we have spoken about so far, every atmosphere, every Kármán line, every satellite, every astronaut who has ever lived, would be hiding in the surface of that single tiny pea, invisible at any normal distance. That is how small our entire vertical journey has been so far on the scale of the system we belong to. The sun is not solid, not in any sense you would recognize. It is a ball of plasma of hot charged gas held together by its own enormous gravity. With a core where temperatures reach around 15 million degrees Celsius, and where every single second roughly 600 million tons of hydrogen are crushed together so violently that they fuse into helium, releasing a torrent of light and heat that over the course of just 1 second equals all the energy human civilization has used in the whole of its history. And our star has been doing this, quietly, steadily, every second, for around 4.5 billion years. It will continue to do so for roughly another 5 billion years before it begins to swell, redden, and finally die. Right now, in this very moment, somewhere near the middle of our sun's life, you are standing on a small wet planet, listening to a voice, while the engine of your entire existence burns and burns and burns above you. Between you and the sun, in the direct line that we are tracing upward, there are no planets at all, because at this moment our line through space points outward, away from the plane in which the inner planets orbit. But if our line happened to pass through the right region of the sky, it could intercept Mercury, the closest planet to the sun, scorched and cratered, only 58 million kilometers from our star. Or Venus, the cloud-shrouded sister of Earth, whose surface, beneath an atmosphere 90 times thicker than ours, broils at over 460 degrees Celsius, hot enough to melt lead. These worlds are part of our neighborhood. They are sometimes, depending on the time of year and the configuration of the orbits, almost directly between us and the sun. And yet, on most days, we forget they are there. Press onward past the sun and you begin to enter a region that takes up almost the entire volume of the solar system, but is so thin, so empty, so quiet, that it is easy to forget it exists. It is called the heliosphere, the bubble of the sun. Our star is not still. It is constantly exhaling a stream of charged particles, a steady wind of protons and electrons, flowing outward in all directions at speeds of hundreds of kilometers per second. This solar wind blows past Mercury, past Venus, past the Earth, sculpting our planet's magnetosphere into its teardrop shape, past Mars, past the asteroid belt, past Jupiter and Saturn and Uranus and Neptune, and onward outward, until at last somewhere in the deep dark beyond the planets it begins to slow, to pile up, to meet gently the wider, ancient interstellar medium, the slow drift of gas and dust that fills the space between stars. And there, at that interface, the heliosphere ends. That boundary is called the heliopause. And it is one of the most extraordinary places in our entire local universe, because crossing it means leaving the influence of our star altogether, entering, in some meaningful sense, true interstellar space. The heliopause sits somewhere between 120 and 160 astronomical units from the Sun, depending on direction and on the rhythm of the solar cycle, roughly 20 billion kilometers away, a distance so vast that it bends the language of distance itself. And there are exactly two human-made objects that have ever crossed it, Voyager 1 and Voyager 2. Two small, silver-faced probes, each weighing less than a small car, each carrying the famous golden records, those gold-plated discs engraved with the sounds and images of our planet, a message in a bottle thrown into the cosmic sea. They were launched in 1977, 49 years ago. They flew past Jupiter, they flew past Saturn. Voyager 2 went on to fly past Uranus and Neptune, the only spacecraft ever to visit those two distant ice giants. And then, having completed their planetary mission, they kept going. They simply kept going, outward, 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 with nothing left to visit and nowhere left to fall. Voyager 1 crossed the heliopause in August of 2012, becoming the first human-made object ever to enter interstellar space. Voyager 2 followed in November of 2018. They are still transmitting. Still, somehow, after nearly half a century, sending faint whispers back across the void to the great dish antennas of the Deep Space Network. As of this year, Voyager 1 is more than 25 billion kilometers from Earth, more than 166 astronomical units away. Voyager 2 is around 21 billion kilometers away. Their radio signals, traveling at the speed of light, now take more than 23 hours to reach us from Voyager 1. A full Earth day just for the whisper to cross the dark. Their power is fading. The plutonium that has fed them for nearly 50 years is running low. One by one, their instruments have been switched off, gently, deliberately, by engineers on Earth to stretch their lives a little longer. Within the next handful of years, perhaps by the early 2030s, the last instruments will go silent. The signals will stop. The two small probes will keep drifting, however, for thousands of years and tens of thousands and millions of years long after our voices have stopped reaching them. Long after the last human who ever helped build them has been forgotten carrying their golden records, their snapshots of Earth, their tiny preserved message of who we were outward into the galaxy, possibly forever. They are, in the deepest sense, the farthest reach of the human species. The two outermost fingertips we have ever extended into the dark. And yet even the Voyagers, even at their staggering distance, are not yet truly far from home. They are still inside what is called the Oort cloud, or at least its inner edge. The Oort cloud is a hypothetical, almost mythological shell of icy bodies, comets in waiting, surrounding our entire solar system at distances stretching out to perhaps 100,000 astronomical units. That is more than 1 light-year. The inner Oort cloud may begin around 2000 AU, and the outer edge may stretch to 100,000. We have never directly seen it. We infer its existence from the long-period comets that occasionally fall inward from those distances, plunging through the inner solar system in long, looping orbits that take thousands or tens of thousands of years to complete. Halley's Comet, on its more familiar shorter loop, is a faint echo of this distant family. The Oort cloud is, in many ways, the true outer boundary of our Sun's gravitational kingdom, and it stretches roughly a quarter of the way to the nearest star. The nearest star. Let that phrase settle for a moment, because beyond the Oort cloud in any direction, the next thing of significance, the next great gravitational island in the dark, is not for a very long time. The nearest stellar system is called Alpha Centauri, and its closest member, a small red dwarf called Proxima Centauri, lies 4.24 light-years away, 40 trillion kilometers. So far that if you sent Voyager 1 in its direction at its current speed, it would take more than 70,000 years to arrive. 70,000 years, the entire span of modern human civilization, several times over, just to reach the nearest star. And between us and Proxima, between our sun and the next, lies almost nothing. Almost. The space between stars is not truly empty. It is filled with a thin, drifting medium of gas and dust, the interstellar medium, with perhaps 1 atom per cubic centimeter in our region, a density so low that it makes the best laboratory vacuums on Earth look crowded by comparison. And folded within that interstellar medium, around us, our sun is currently passing through a particular pocket called the local interstellar cloud, a small, warm, wispy region of gas about 30 light-years across. The local interstellar cloud is itself drifting through a much larger structure called the local bubble, a vast cavity in the interstellar medium, hundreds of light-years across, carved out, astronomers now believe, by a chain of supernova explosions that detonated some 10 to 20 million years ago. We are, at this very moment, sailing through the inside of an ancient blast cavity, the long-cooled fossil of the deaths of stars that died before our species had even begun to walk upright. That is what sits, directly above your head, when you push the line out far enough. Not just sky, not just space, not just the sun, but a bubble carved by dying stars, a neighborhood shaped by ancient catastrophe, and we, riding inside it, hardly ever look up long enough to notice. So I want to ask you something, and I want you to sit with it. Of all the celestial objects we have traveled past on this climb, so far the clouds in the troposphere, the auroras in the thermosphere, the satellites in low orbit, the moon, the sun, the planets. The Voyagers carrying their golden, whispers the heliopause, the nearest star. Which of them, honestly, do you feel the most connected to? Which one tugs at something inside you, makes you want to look up, makes you want to step outside on a clear night and find it, or imagine it, or simply know it is there? There is no wrong answer. Some people feel kinship with the moon. Some feel it with a particular planet that has, for whatever reason, captured them since childhood. Some feel it with the Voyagers, those small, lonely emissaries. I would love to know which one is yours and why, because we have not yet reached the largest scale. We are still inside the sun's small kingdom. Step further outward, and our entire solar system, with its planets and its Oort cloud and its slowly fading probes, becomes nothing more than a single bright pinprick in something far, far larger. A vast, slowly turning disk of 200 billion stars, in which our sun is one quiet member, drifting in a quiet suburb in a quiet arm. And it is to that turning disk, that great spiraling wheel of light, that our line through space is climbing next. Pull back. Pull back further. Imagine you could rise above the entire solar system, far enough that the sun itself becomes a single bright dot, and the Oort cloud, that vast shell of dormant comets, shrinks to a faint smudge around it. From this vantage, our entire kingdom of planets and probes and golden records, The kingdom whose boundary the voyagers spent 40 years trying to reach becomes nothing more than a tiny luminous mote, almost lost in the dark. And then slowly, as you keep pulling back, a much larger structure begins to come into view. A great, slow, spiraling wheel of light, 200 billion stars or more, arranged in graceful curving arms turning together around a common center. The Milky Way, our galaxy, our home. The Milky Way is roughly 100,000 light-years across. Let that number breathe. 100,000 light-years. A light-year is the distance that light, the fastest thing in the universe, travels in 1 year, and that distance alone is nearly 10 trillion kilometers. So 100,000 light-years is a number so vast that the human mind cannot truly hold it. To put it gently into scale, if you shrank the Milky Way down to the size of a continent, our entire solar system, with the sun and the planets and the voyagers and the Oort cloud all included, would be smaller than a single grain of fine sand on a beach somewhere in that continent. We are not even a feature of the galaxy. We are barely a speck inside one of its quiet outer neighborhoods. Our sun lives in a region called the Orion Arm. Sometimes it is called the Orion Spur, because compared to the great major spiral arms of the galaxy, the Perseus Arm, the Sagittarius Arm, the Scutum Centaurus Arm, our local stretch of stars is a smaller, more modest feature, a kind of suburban offshoot tucked between two grander avenues. We are about 26,000 light-years from the galactic center, roughly halfway out from the middle, in a peaceful part of the disk, far from the violent, crowded interior, where stars are packed densely together and supernovae detonate more often, and far from the thin outer edge, where the disk thins into a faint halo of older stars. We live, in galactic terms, in a quiet town, a safe distance from anything too dramatic. And there is, perhaps, a kind of poetry in the fact that life on Earth was able to evolve over billions of unbroken years, in part because we happen to live in such a calm and forgiving address. At the very center of the Milky Way, 26,000 light-years from your front door, sits a beast, a supermassive black hole with a mass of more than 4 million suns, compressed into a region smaller than our solar system. Its name is Sagittarius A star, and in May of 2022, the Event Horizon Telescope collaboration released the first ever direct image of it, a glowing ring of hot gas around a dark central shadow, the silhouette of the monster at the heart of our home. It is not pulling us in. It is not, on the timescales of human civilization, doing anything dramatic at all. It simply sits there, at the gravitational hub of 200 billion stars, anchoring the slow, majestic rotation of the entire galaxy. Our sun orbits it once every 220 to 250 million years, moving at around 800,000 kilometers per hour. The last time the sun was in this same position in its galactic orbit, dinosaurs had not yet evolved. The next time it returns, no one knows what, if anything, will be here to notice. And the galaxy is not still, not stable, not finished. It is in motion. It is, in fact, on a collision course. Roughly 2.5 million light-years away in the direction of the constellation Andromeda sits our nearest large galactic neighbor, the Andromeda Galaxy, a spiral similar to ours, though probably somewhat larger, with perhaps 1 trillion stars of its own, and Andromeda is falling toward us. Pulled by the mutual gravity of our two galaxies, it is approaching at around 110 kilometers per second. In roughly 4 to 5 billion years, the two galaxies will meet. They will not collide in the way solid objects collide. The stars inside them are so far apart that almost none will physically strike one another. But the two galaxies will pass through each other, twist around each other, tear each other into long luminous streamers, fall back together, and over the course of several billion years more, merge into a single new, larger, elliptical galaxy. Some astronomers have begun to call this future merged object Milkomeda. Our sun, by then, will still be alive, though aged. Earth, if it has not already been baked dry by the slowly brightening sun, will be a very different place, or it will be gone entirely. And the night sky of whatever world inherits this region of space will look unrecognizable. The Milky Way and Andromeda are not alone. They are bound together, along with about 100 smaller galaxies, in a gravitationally connected family called the Local Group. The Local Group is roughly 10 million light-years across, a small island of associated galaxies floating in the dark. Within it, our Milky Way and Andromeda are the two giants. The third largest member, the Triangulum Galaxy, is much smaller and orbits at the edge of our family. The rest are dwarfs. Some, like the Large and Small Magellanic Clouds, visible from the southern hemisphere as soft glowing patches in the night sky, are satellites of our own galaxy, slowly being torn apart and consumed. Pull back further still. The Local Group is itself only a small member of a much larger structure. A vast cluster of galaxies called the Virgo supercluster, containing thousands of galaxies and stretching across more than 100 million light-years. And for many decades, astronomers thought that was where our cosmic address ended. The Virgo supercluster, our great home of galaxies, our truest neighborhood on the largest scale we knew. And then, in 2014, a team of astronomers led by Brent Tully and his colleagues, working with new techniques to map the motions of galaxies, made a quiet and astonishing discovery. They discovered that the Virgo supercluster is not, in fact, a self-contained structure. It is itself a small lobe of something far greater. They mapped the great flowing currents of galaxies, the directions in which galaxies were being pulled by the gravity of all the matter around them, and they found that all of those flows, for hundreds of millions of light-years in every direction, were converging toward a single, immense gravitational basin. They named the new structure Laniakea, a Hawaiian word meaning immeasurable heaven. The Laniakea supercluster is approximately 500 million light-years across. It contains 100,000 galaxies. And our entire Local Group, including our entire Milky Way, including everything we have spoken about tonight, is being slowly pulled, along with countless other galaxies, toward a region within Laniakea called the Great Attractor. We are falling, all of us, together, toward something so massive, so distant, so quietly powerful, that we do not even fully understand what it is. And Laniakea, immeasurable heaven, is itself only one node in a still larger pattern. Because when astronomers look at the universe on the very largest scales, they see something that resembles more than anything else, a vast three-dimensional foam, a web, a network of luminous filaments, threads made of galaxies and clusters and superclusters, woven together across hundreds of millions of light-years, surrounding enormous empty voids, regions of space where there are almost no galaxies at all, where the dark stretches uninterrupted for hundreds of millions of light-years. This is called the cosmic web. It is the largest known structure of the universe. Galaxies are not scattered evenly through space. They are strung along the filaments of this web, like dew along the threads of an immense spider's silk, with vast empty rooms in between. And our galaxy, our Local Group, our Laniakea, are all one tiny set of beads on one strand of one filament, in a web that stretches across the entire observable universe. The observable universe, the largest structure we can speak of meaningfully at all. It is a sphere centered on the Earth, with a radius of about 46.5 billion light-years, which means a diameter of about 93 billion light-years. Within it lie, by current estimates, somewhere between 200 billion and 2 trillion galaxies. The recent observations from the James Webb Space Telescope, sitting 1.5 million kilometers above your head at the L2 Lagrange point we spoke of earlier, have begun to reveal galaxies that formed astonishingly early within just a few hundred million years after the Big Bang. Galaxies that appear larger and more mature than our previous theories predicted. The picture is shifting. The numbers are growing. And the universe is, quietly, turning out to be even stranger, even older, even richer than we had imagined. And here is the thing that humbles me, perhaps more than anything else. The observable universe is only what we can see. It is the sphere from which light has had time to reach us, in the roughly 13.8 billion years since the Big Bang. Beyond that sphere, the universe almost certainly continues. We do not know how far. It may be much larger than what we can see. It may be infinite. We genuinely do not know. There may be entire realms of cosmic web, entire continents of structure, that lie forever beyond the horizon of our sight, simply because the light from them has not had time to arrive, and perhaps, due to the accelerating expansion of space, never will. There are galaxies out there almost certainly that we will never see, that no one will ever see, that are receding from us faster than light can cross the gap. Let that thought settle for a moment, above your head, above the troposphere, above the Kármán line. Above the Moon, the Sun, the heliopause, Proxima Centauri, the Orion Arm, the galactic center, Andromeda, the local group, the Virgo supercluster, Laniakea, the cosmic web, the observable universe. There is possibly more, possibly an infinity more. And all of it sits, in some sense, directly above your head right now, along the line we have been tracing upward together since you took your first breath in this video. So I want to ask you, very quietly, how does that make you feel? Not what does it make you think. What does it make you feel in your chest, in your stomach, in the small animal part of you that has always known the size of a room but cannot quite grasp the size of a galaxy? Does it frighten you? Does it comfort you? Does it make you feel small, or, strangely, larger, because you are the kind of creature who can hold such an idea inside a single fragile mind? There is no correct answer. But I would love to know which one is true for you tonight, lying there, looking at a ceiling that is not really a ceiling at all, because we have climbed as far upward as our line can carry us. There is nothing more above. Or rather, there is everything above, and we will never see the end of it. So now, gently, slowly, it is time to turn around, to look down, to follow that same line in the opposite direction through the floor beneath your feet, through the crust, through the mantle, through the molten heart of our planet, and find out what exactly has been waiting underneath you all this time, all your life, while you have been so busy looking up. Lie still for a moment. Let your weight settle. Feel the small pressure of your body against the surface beneath you. The bed, the chair, the floor, whatever holds you, and now turn your attention inward and downward, through the fabric beneath your skin, through the wood or the concrete or the carpet under your feet, through the foundation of your home, the soil of your garden, the bedrock beneath your city. Imagine the line we have been tracing, that vertical line drawn straight down from the crown of your head, continuing through all of that, and onward deeper, deeper still. Where does it go? What does it pass through? And how long, how unimaginably long, does it travel before it finally meets the very center of the earth? The answer is this. From wherever you are listening, right now, the center of the earth lies approximately 6,371 kilometers beneath you. That is the average. It varies slightly because the earth is not a perfect sphere. It is a little flattened at the poles and bulges a little at the equator. So if you are listening from somewhere near the equator, the journey to the center is a touch longer, around 6,378 kilometers. If you are listening from near one of the poles, the journey is a touch shorter, about 6,357 kilometers. But the difference is small. 6,133 kilometers, give or take. That is the depth of the line beneath you. To put that number in scale, 6,371 kilometers is, very roughly, the distance from London to New York, from Tokyo to Sydney, from Cairo to Cape Town. A flight that, on the surface, you might board in the morning and finish before dinner, with a movie and a few meals along the way. That same distance, drawn straight downward instead of horizontally, takes you from the soles of your feet to the deepest, hottest, strangest point in our entire planet. And we have, as a species, never been more than a tiny fraction of the way there. The deepest hole humans have ever drilled into the Earth is a place called the Kola Superdeep Borehole, in the far north of Russia, near the Norwegian border. The Soviet Union began drilling it in 1970, in a quiet and quietly competitive answer to the American Apollo program. While the Americans were reaching outward to the moon, the Soviets decided to reach inward into the Earth itself. And for nearly 25 years, with great patience and immense engineering effort, their drill went down, and down, and down. In 1989, after almost 2 decades of work, the Kola borehole reached its maximum depth, 12,262 meters, 12 kilometers almost exactly. And there, the drilling stopped, because the rocks at that depth were no longer behaving like rocks. They were behaving like plastic. The temperatures, expected to be around 100 degrees Celsius, were instead nearly 180. The hole began to slowly close in on itself, like a wound trying to heal. The equipment could go no further. The Soviets shut down the project. And there, more than 3 decades later, the borehole still exists, capped over, abandoned, with a small rusted metal plate covering the top of the deepest scratch human beings have ever made into the skin of our world. 12 kilometers. Think of that for a moment. We have walked 12 kilometers in an afternoon, on a long, peaceful hike. 12 kilometers is the height of a typical commercial airliner's cruising altitude. It is less than the depth of the Mariana Trench in the Pacific Ocean, which reaches nearly 11 kilometers below the sea surface. And it is essentially nothing compared to the 6,371 kilometers that separate the surface of the Earth from its center. If our planet were a perfect apple, the Kola borehole would not even pierce the apple's skin. It would barely scratch the wax. The deepest reach of humanity into our own planet, accomplished over nearly a quarter-century of effort, is a pinprick that did not even leave the outermost layer. That outermost layer is called the crust, and it is, surprisingly, very thin. The continental crust, the part beneath the landmasses where most of us live, is on average about 30 to 40 kilometers thick, with the thickest sections, beneath great mountain ranges like the Himalayas and the Andes, extending to perhaps 70 kilometers down. The oceanic crust, the kind that forms the floors of the deep oceans, is even thinner, often only 5 to 10 kilometers thick, freshly created at mid-ocean ridges where molten rock rises from below and pushed outward by the slow, patient motion of the plates. If you could peel the crust off the Earth like the skin off a peach, what remained would be a smooth, immense sphere of dark rock, with a curious thin layer of granite and basalt sitting on top of it like a fragile rind. And on the upper face of that rind, in a film just a few meters thick, lives every single living thing we have ever known. Just below the crust, separated by a strange and famous boundary called the Mohorovičić discontinuity, the MOHO for short, named after the Croatian seismologist who first discovered it in 1909, lies the mantle. The mantle is by far the largest single region of the Earth by volume. It begins at the base of the crust, anywhere from 5 to 70 kilometers down, depending on where you stand, and it extends all the way to a depth of about 2,900 kilometers, almost half the way to the center of the planet. It is made primarily of dense silicate rocks, rich in iron and magnesium, and although we sometimes describe it casually as molten, the truth is more subtle. The mantle is, in most of its volume, technically solid. But it is hot and under enormous pressure, and on the timescales of millions of years it flows, slowly, patiently, like a glacier creeping downhill, like honey forgetting that it is honey. Within the mantle there are several distinct regions. The uppermost mantle, together with the crust, forms what is called the lithosphere, the rigid outer shell of the planet, broken into the great tectonic plates that drift slowly across the surface, carrying continents on their backs, raising mountains where they collide, opening oceans where they part. Below the lithosphere lies the asthenosphere, a region of slightly softer, more pliable rock, beginning roughly 100 kilometers down and extending to perhaps 350 kilometers, on which the Great Plates slide. The asthenosphere is the reason continents drift, the reason earthquakes happen, the reason mountains rise and fall on timescales of millions of years. Without it, the Earth's surface would be frozen, immobile, unable to recycle itself. With it, our planet remains, in a sense, alive. Deeper still, between about 400 and 700 kilometers down, lies a region called the mantle transition zone, where the minerals of the upper mantle, under increasing pressure, rearrange their atomic structures and become denser forms. And below that, from about 700 kilometers to nearly 2,900 kilometers down, lies the lower mantle, the vast, dark, unimaginably hot belly of the planet. Pressures here reach more than 1,000,000 times atmospheric pressure. Temperatures reach 2 to 3,000 degrees Celsius. And no human being, no instrument, no probe has ever directly observed this region. Not even close. We have never sampled the lower mantle. We have never seen it with our eyes. Everything we know about it, we have learned in a strange, indirect, almost ghostly way. Through earthquakes. Earthquakes are violent for those who live through them. But for seismologists, every earthquake is also a gift, because the waves of energy released by a quake travel outward in all directions, including downward, into the interior of the planet. Some of those waves, called P waves, can travel through both solids and liquids. Others, called S waves, can travel only through solids. They are blocked entirely by liquid layers. By placing sensitive instruments called seismometers all over the surface of the planet and listening patiently to the way these waves bend and slow and reflect and disappear as they pass through the deep interior, scientists have built up over more than a century a detailed picture of what the inside of the Earth must look like. We have never been there. We probably never will be, but we have heard it. We have listened to the bell of our planet ring after every earthquake, and from the music of those ringing tones, we have learned the structure of what lies beneath. It was in this way, in 1909, that Andrija Mohorovičić first noticed the discontinuity that now bears his name. By studying how seismic waves from a Croatian earthquake suddenly sped up as they crossed a particular depth, revealing the sharp boundary between crust and mantle. It was in this way, in 1914, that Benoit Gutenberg identified another boundary much deeper, where S-waves abruptly vanished, suggesting that beneath a certain depth the interior of the Earth must be liquid. And it was in this way in 1936 that Inge Lehmann, a Danish seismologist, listening carefully to the records of a large earthquake in New Zealand, noticed faint reflections that had no right to exist and realized that within the liquid outer core there must be a smaller solid inner core, a heart within a heart. And in the last few years, since around 2023, the listening has gotten still finer. Listening to the way seismic waves from very specific earthquakes pass through the deepest center of the planet, seismologists have begun to confirm something even stranger. That within the inner core itself, there appears to be yet another distinct innermost region, an innermost inner core, perhaps 650 kilometers across, with iron crystals aligned in a different orientation from those of the surrounding inner core. A core within a core within a core. We are still in the early years of understanding what it is and what it means. But the picture we are forming, the picture of what sits directly beneath your feet, is more layered, more nested, more intricate than even the geologists of one generation ago dared to imagine. So I want to ask you something. Have you ever in your life felt an earthquake? A real one. The sudden, soft, unsettling realization that the floor beneath you, the floor you have trusted your entire life, is no longer perfectly still. If you have, do you remember the strange disorientation of it? The small primal panic when the most solid thing in the world reveals itself to be, in some hidden sense, alive. And if you have never felt one, can you imagine what it would mean to know, viscerally, that the ground beneath you is not a foundation but a thin shifting raft, floating on a slow river of hot stone? I would love to know your experience of it. Where you were, what you felt, whether it changed even a little the way you think about what is below, because we have only descended about halfway. The moho, the asthenosphere, the transition zone, the lower mantle. 2,900 kilometers of rock, slowly flowing, slowly seething, holding up everything you have ever loved. And beneath all of that, still waiting, lies something even stranger, something liquid, something molten, something spinning. A vast ocean of iron, larger than the moon itself, hidden inside our planet, generating the magnetic shield that protects every breath you take. And it is to that hidden ocean, and to the secret heart it surrounds, that we are about to descend next. At a depth of approximately 2,900 kilometers, almost halfway to the center of the Earth, our descending line crosses one of the most dramatic boundaries on the entire planet. It is called the Cormantle Boundary, or sometimes the Gutenberg Discontinuity, after Benno Gutenberg, the seismologist who first inferred its existence more than 100 years ago. And it is, in many ways, the most violent and least understood interface in our world. Above it, the lower mantle is solid rock, dense and hot but rigid. Below it, suddenly, everything changes. The rock gives way to metal, the solid gives way to liquid. The familiar mineral chemistry of silicates and oxides gives way to a swirling ocean of molten iron and nickel, with traces of lighter elements whose precise identity is still debated. You have crossed into the outer core, and you are now inside something that has no analog anywhere else on Earth. The outer core is enormous. It extends from the Cormantle boundary down to a depth of about 5,150 kilometers, a thickness of roughly 2,200 kilometers. If you somehow lifted the outer core out of the planet and laid it on the surface, it would be a body larger than our moon. A vast spherical shell of liquid metal, hidden inside our world, between the slowly flowing rocks of the mantle and the strange solid heart at the very center. And it is in constant motion. Not the slow, glacial creep of the mantle, but a true, fluid, turbulent flow, driven by heat escaping outward and by the rotation of the planet itself. This is, in a sense, the engine room of our world. Because as the molten iron of the outer core swirls and convects, carrying charged particles around with it, it generates electric currents. And those electric currents, in turn, generate the great magnetic field that surrounds our entire planet, the magnetosphere that we spoke of earlier. That vast teardrop bubble extending tens of thousands of kilometers into space, deflecting the solar wind, shielding the atmosphere from being stripped away, allowing aurora to dance at the poles, allowing life to persist on the surface, all of it, every invisible field line. Every magnetic compass needle that has ever pointed north, every migrating bird that ever used the field to navigate, every shielded astronaut, every protected breath, all of it, traces back to this restless ocean of molten iron swirling thousands of kilometers below your feet at this very moment. The geodynamo. The engine. Without it, the atmosphere would slowly bleed away into space. Without it, the surface would be sterilized by radiation. Without it, the Earth would be Mars, a red, dry, ancient corpse of a world. With it, we are alive, and the field is not constant, it wanders. The magnetic North Pole, the point on the Earth's surface where compass needles point, has been drifting for as long as we have been measuring it, and in recent decades the drift has been notably faster. Through most of the 20th century, magnetic north moved at a few kilometers per year. By the 1990s, it had accelerated to tens of kilometers per year. In recent years, it has been racing across the high Arctic, sometimes covering more than 50 kilometers in a single year, sliding away from northern Canada towards Siberia. We do not fully understand why. And on much longer timescales of hundreds of thousands of years, the field does something even more remarkable. It reverses. North becomes south. South becomes north. The last full reversal, called the Brunhes-Matayama reversal, occurred about 780,000 years ago. Several partial excursions have happened since. There is no reliable way to predict when the next will occur. It may be tens of thousands of years away. It may be sooner. And when it happens, the field will weaken, perhaps dramatically, for a period of centuries to millennia, before re-establishing itself in the opposite orientation. We have no fossil record of life being meaningfully damaged by previous reversals, but we have also never tried to operate a satellite-dependent civilization through one. All of this, the field, the reversals, the engine, the great molten ocean, all of it pours forth from the outer core. And yet the outer core, vast as it is not the very center. There is one more layer to descend, one last frontier. At a depth of approximately 5,150 kilometers below the surface, the liquid metal of the outer core gives way to something solid again. A boundary so sharp and so distinct that, when N. G. Lehman discovered it in 1936 by tracing faint reflections of seismic waves, she realized she was looking at one of the most extraordinary structures in the entire Earth. A solid sphere of iron and nickel, roughly 1,220 kilometers in radius, sitting at the very heart of our planet, suspended in liquid metal like a great hot pearl. The inner core, the deepest place on Earth. The conditions there are almost unimaginable. The pressure at the center of the Earth is about 3.5 million times atmospheric pressure. The temperature is estimated at somewhere between 5,000 and 6,000 degrees Celsius, which is, remarkably, comparable to the temperature of the surface of the Sun. Hot enough in any reasonable circumstance on the surface to vaporize iron entirely. And yet here, at the center of the planet, under that crushing pressure, the iron is solid. It is forced into a crystalline form that does not exist anywhere else, with atoms packed so tightly that the metal behaves in ways we are still trying to understand. There is a small sun at the center of the Earth. Not glowing with fusion, not pouring out light but matching its surface temperature made of iron, locked in solid crystal, slowly growing larger across geological time as the outer core, layer by layer, freezes onto its surface. The inner core is young, in geological terms. We do not know exactly when it began to form. Estimates have ranged anywhere from over 1 billion to less than 1 billion years ago, with much active debate in the scientific community. As the Earth has slowly cooled over its 4.5 billion year history, the outer core has been freezing inward, dropping its lightest elements upward to drive the convection that powers the magnetic field, and adding its heavier crystalline iron to the growing inner core below. The inner core grows by something on the order of 1 millimeter per year, almost nothing on a human scale, enormous on a planetary scale, every century a few centimeters, every million years a few kilometers, patient, relentless, ancient. The heart of the Earth is, very slowly, getting larger. And it is spinning. This is one of the strangest facts about it. Because the inner core is a solid body surrounded by a liquid outer core, mechanically decoupled from the mantle above, it can, in principle, rotate at a slightly different speed than the rest of the planet. And for decades, seismologists have been arguing about exactly how it does this. In the 1990s, careful studies of seismic waves passing through the inner core suggested that it was rotating slightly faster than the mantle, perhaps gaining a fraction of a degree per year, a phenomenon called superrotation. The picture was elegant. The center of the planet very slowly leading the rest of the world in its great spin. And then, in 2023, a study by Yi Yang and Xiaodong Song, published in Nature Geoscience, made headlines worldwide. By analyzing decades of seismic data from repeating earthquakes, the researchers found evidence that the superrotation of the inner core had slowed dramatically in the early 2010s and may have stopped entirely, perhaps even begun to rotate slightly in the opposite direction relative to the surface. A reversal. A reversal at the very heart of the planet. The headlines predictably were alarming. Some declared that the core had stopped, that something was wrong, that catastrophe was imminent. None of that is true. The shift is tiny in the range of fractions of a degree per year. Far too small to be felt at the surface, and almost certainly part of a much longer oscillation. Perhaps a multi-decade cycle in which the inner core slowly speeds ahead, and then falls behind the mantle again and again. In a quiet rhythm that we are only just beginning to perceive. Follow-up studies in 2024, including independent work analyzing waveform data over different decades, have largely supported the picture of a slowdown and a possible reversal. The inner core, it seems, is not constant. It is breathing, slowly, patiently, in and out on a timescale of decades. And the deepest secret of all, the one we glimpsed only in the last paragraph of the last section, is this. Within the inner core, there appears to be yet another, even more central region. An innermost inner core. Through painstaking analysis of seismic waves passing through the deepest of the deep seismologists, including a team led by Than Sun Ph. Letter 1EA1M and H. Harvoj T. Kalchik working at the Australian National University, and published in Nature Communications in 2023, have found evidence of a distinct central region. Perhaps 650 kilometers across, in which the iron crystals appear to be aligned in a different orientation than in the outer parts of the inner core. The implication is profound. The inner core, we now think, may have formed in two stages. First, an early primitive inner core with its own pattern of crystal alignment formed in the deep past. Then, at some later point, conditions changed, and the inner core resumed growing, but with a slightly different orientation of crystals, building outward around the earlier heart. A core within a core within a core, a fossil at the center of the world of an earlier event in our planet's history. Let that idea live in your mind for a moment. Right now, 6,000 kilometers beneath your body at the very center of the Earth, there is in essence a record, a signature. A faint but unmistakable echo of something that happened to our planet long ago, perhaps 500 million years ago, perhaps more, an event so significant that it changed the way the iron at the very center crystallized. We do not yet know what that event was. The most popular hypothesis involves a major change in the way the outer core convects, perhaps connected to the formation or movement of large structures in the deep mantle above. But the truth is, we are still listening, still piecing it together, still learning, year by year, what our own planet has been hiding in its heart for as long as life has existed on its surface. And all of this, every layer, the crust, the mantle, the outer core, the innermost inner core has been here, beneath you. Every step of your life, every night you have ever slept, every word you have ever spoken, every dream you have ever dreamed. While you have been walking around, paying attention to your work, to your loved ones, to your worries, to your phone, this great layered architecture has been quietly turning, quietly burning, quietly generating the very field that protects you, quietly hiding its ancient secrets beneath your feet. And you have, almost certainly, never given it a single conscious thought on most of the days of your life. So I want to ask you something gently. Have you ever, in a quiet moment, paused to think about what is directly underneath you in that very instant? Not in a casual, theoretical way, but truly, in the sense of a vertical line drawn from your feet, downward through the floor, through the soil, through the bedrock, through 6,000 kilometers of rock and metal, to a small ancient solid heart at the center of the planet. Have you ever felt the weight of it, the age of it, the fact that, in a sense, you are not standing on the Earth at all? You are standing on a very thin film, on top of an immense layered ocean of fire and stone. And it has been holding you up faithfully your entire life. I would love to know if you have ever felt that, whether the thought brings you comfort or unease or something quieter than either. Because now, having reached the deepest point our line can carry us, we come to a strange and beautiful question. What happens if we keep going? What happens if our line does not stop at the center of the Earth but passes straight through it and continues outward on the other side? Because, as you may already be beginning to sense, our line does not stop. It cannot. A line through a sphere does not end at the center. It comes out the other side. And what waits on the other side of the Earth, directly opposite from where you are standing right now, is something almost no one ever thinks about. It is a place. A real place with its own sky, its own depth, its own version of above and below. And it is almost certainly somewhere you have never been. Stay with the image for a moment. The line we have been tracing has now passed through the very center of the Earth. It has crossed the innermost inner core. It has emerged from the other side, and it is rising again upward through the deep iron, through the molten outer ocean, through the lower mantle, through the asthenosphere, through the crust, and finally breaking the surface. On the exact opposite side of our planet from where you are now. This place, the geometric mirror of your location on the globe, has a name. It is called your antipode, and almost certainly, it is somewhere you have never set foot. Here is a curious truth that most people never stop to consider. The Earth's surface is about 71% ocean, and because of the particular way the continents are arranged on our planet, with most of the land concentrated in the northern hemisphere and most of the great oceans, especially the vast Pacific dominating the southern, the chances that the place directly opposite from where you are listening is dry land are very, very small. For most of the people who have ever lived on Earth, their antipode is water. Open, empty, deep ocean. Probably one of the loneliest stretches of the Pacific, far from any shipping lane, far from any island, far from any human soul. If you are listening from somewhere in Europe, your antipode is almost certainly a point in the South Pacific Ocean, several thousand kilometers from any landmass, far southeast of New Zealand. If you are listening from the eastern United States, your antipode is likely somewhere in the Indian Ocean, west of Australia. If you are listening from China, you might be standing across from a stretch of South Atlantic, or a piece of Argentina if you are particularly lucky. There are few places where land does sit across from land. New Zealand has its antipode in Spain and Portugal, which is, charmingly, why the Antipodes Islands south of New Zealand are named the way they are. Parts of Argentina and Chile lie roughly opposite parts of mainland China. The Philippines have an antipode in Brazil, but for most of the inhabited world the answer is the same. Across from where you are, on the other side of the world, there is water. Cold, deep, unwitnessed water, rolling under a sky that no one is looking at, in a place that has, almost certainly, never been touched by anyone you have ever known. And yet, here is the strange thing. If you somehow stood at your antipode, on the surface of the ocean, or on some imagined floating platform, and you looked down, you would see another line stretching beneath your feet. And it would lead through the crust, through the mantle, through the outer core, through the inner core, through the innermost inner core, through everything we have spent these long hours descending through, back to you. Your line and theirs are the same line. The same 6,371 kilometers of layered planet, the same molten ocean, the same ancient heart. They are looking down at exactly what you are looking down at, only in reverse. And if they looked up, they would see a sky just as deep as yours, just as crowded with invisible layers, just as open to the same moon, the same sun, the same nearest stars, the same Milky Way, the same local group, the same Laniakea, the same cosmic web. Their above is also our above, when seen from far enough away. Pause on that. Let it tilt your sense of orientation just slightly, because here is the first quiet crack in the very premise of this entire journey. The line that we have been calling down when traced far enough comes back out as up. Down is not a destination. Down is a direction that loops. Down, on a sphere, is simply the shortest path through to the other side of the sky. Your antipode is not beneath you. Your antipode is, in the deepest sense, also above you, just very, very far away on the wrong side of a great round planet. Think about how many people have, at some moment in their childhood, imagined digging a hole straight through the earth. The classic question: if you started digging in your backyard, where would you come out? Generations of children in countries all over the world have asked their parents some version of this, and the most common answer, given confidently and almost always wrongly, has been China. American children grow up being told that if they dig straight down, they will reach China. But for almost anyone in the United States, this is geometrically impossible. The antipode of the continental United States lies in the southern Indian Ocean. China sits on roughly the same hemisphere as the United States in terms of the curve of the planet. The childhood myth is, like so many childhood myths, a comfortable fiction. The truth is stranger and lonelier. The truth is that, for most American children, if they could really dig straight down, they would come out into a cold, gray ocean, with no land in sight, far from any human civilization, in some of the most unvisited water on Earth. And there is another truth, even stranger. You cannot actually dig that hole. You never could. Even setting aside the absurdity of trying to drill through 6,000 kilometers of solid and molten rock and metal. Even setting aside the fact that the deepest borehole humans have ever made reached only 12 of those kilometers before the rock began to flow like wax, even setting aside all of that, there is the simple matter of temperature. The interior of the Earth is hot. Catastrophically, unimaginably hot. Anything we lowered into it would melt long before it reached the inner core. The hole could not be lined. The walls could not hold. The very materials we know of would liquefy, burn, vaporize. The childhood image, the neat clean tube straight through the earth, with a small figure climbing through it like a worm through an apple, is impossible in every physical respect. But the thought experiment itself is still useful. Because if such a hole could exist somehow with magical walls and you stepped into it at one end and let yourself fall, something fascinating would happen. You would not fall faster and faster forever. You would accelerate, yes, downward, pulled by gravity, gaining speed as you went. But as you approached the center of the earth, the gravity acting on you would begin to change. Because gravity is a pull from mass, and as you descend, more and more of the Earth's mass is above you, pulling you back, while less and less is below you, pulling you forward. By the time you reach the very center, the pulls from all directions would cancel out, and you would, for a brief instant, be weightless. Right there, at the heart of the world, floating, with every direction equally up and equally down. And then you would continue by sheer momentum past the center and out toward the other side, decelerating now, slowing, until in theory you would just barely reach the surface at your antipode, where you would, almost gently, come to a stop. And then, if no one caught you, you would fall back the other way, oscillating back and forth through the center of the planet every 42 minutes or so forever. A human pendulum swinging through the heart of the world. It is a beautiful thought. And it is also, of course, completely impossible. But the geometry is real. The geometry is the same geometry that holds you here, that holds the antipodal ocean in place, that ties your sky to theirs, that connects your line to theirs through the same molten heart. You and a stretch of empty water on the other side of the planet are gravitationally linked, mirrored, paired. You belong to each other in a way you will never see. I want to ask you something. Do you know off the top of your head where your antipode is? If you stood up right now and drew a line straight down through the earth, where on the surface would it emerge? Most people have never thought to ask. Most people, if pressed, would guess wrongly. Try to picture it. Imagine the rough latitude where you are listening. Now flip it across the equator. Imagine the rough longitude where you are listening. Now add or subtract 180 degrees. Where does that put you? Almost certainly somewhere in the ocean, somewhere you have never been, somewhere in this very moment where no one is looking back, where the waves are rolling under a quiet sky with absolutely no awareness that, on the opposite side of the planet, a person is lying still, listening to a voice, thinking, for perhaps the first time, about that exact stretch of empty water as a kind of mirror. I would love to know where your antipode is. Look it up sometime if you have not. There is something quietly moving about finding the precise point on the globe that is, in this strict geometric sense, the most distant place from you that exists. Because the realization at the antipode is, in many ways, the turning point of our journey tonight. Up until this moment, we have been tracing a line. Above, below. Two arrows, two directions, two simple words inherited from childhood, and we have followed those arrows faithfully. Upward through the atmosphere, through the satellites, past the moon, past the sun, through the heliosphere, past the Voyagers, past the nearest star, into the galaxy, into the local group, into Laniakea, into the cosmic web. Downward through the crust, through the mantle, through the outer core, through the inner core, through the innermost inner core, through everything we have ever called solid ground. And we have learned in tracing those two arrows that they are not symmetric. Above is open. Above is infinite, possibly, almost certainly. Above keeps going. Below, by contrast, has a center. Below has a heart. Below loops back. Below, traced far enough, becomes above again on the other side of the world. Which is to say, the very framing of this question has been quietly misleading us the entire time. There is no down, not really. There is no up. There is only out from a surface in every possible direction. Stand on a different part of the planet, and your above and below swap. The astronaut on the International Space Station, looking down at Australia, sees what for an Australian is up. The fish in the Pacific Ocean above your antipode is, in a strict geometric sense, beneath you, but also equally above you, depending on where the line is drawn. We have been climbing all evening, through a single direction we invented because we have feet and the earth has gravity. But the universe does not know about feet. The universe does not know about ceilings. The universe does not know about above and below at all. And once you let that thought in, once you let that crack widen, the whole picture begins to shift. The earth is not a stage with a floor and a sky. The earth is a small round island, floating in the dark, with a thin film of life around it and a layered interior beneath it, and a vast unbounded openness in every direction beyond its surface. The moon does not hang in the sky. The moon orbits in the dark alongside us, slightly outward from our planet. The sun is not above. The sun is, depending on the moment of the day and the part of the planet you stand on, in front of, beside, beneath, or behind us. The whole vocabulary of above and below begins to look like what it really is. A small, useful, local invention. A piece of grammar for creatures who never leave the surface. Beyond the surface, the words simply do not apply. We are about to feel the full force of that dissolution, because there is still one more layer of the story to tell, one last expansion of perspective. Once we step off the planet entirely, once we look down at the earth from somewhere outside it, the meaning of above and below collapses completely. And in collapsing, it reveals something quieter and stranger, and more humbling than any of the layers we have yet seen. It reveals that this entire journey, this entire long vertical line we have been climbing, has been in a very real sense an illusion of language. There is only the earth, and the dark around it, and us briefly inside our own atmosphere looking out. Imagine then that you could step off, just briefly. Imagine you could leave your body where it is, lying still, listening, and rise, not in any literal sense, not through any layer we have already crossed, but in imagination, gently, like a soft balloon, lifting away from the surface of the earth, up through the troposphere, through the stratosphere, through the mesosphere, through the thermosphere, through the exosphere, past the Kármán line, past the Van Allen belts, past the International Space Station, past the geostationary satellites, until you are far enough out, perhaps a few 100,000 kilometers away, that you can see the whole Earth at once. A single blue-white sphere suspended in the dark, slowly turning, and you, floating, weightless, looking at her. From here, where is up? Where is down? Look around. There is no ceiling. There is no floor. There is only the earth in front of you and the immense black sea of space in every direction, scattered with the cold pinpoints of distant stars. If you turn your head one way, you see the earth. If you turn your head the other way, you see space. If you spin yourself around in any direction, the universe simply unfolds around you, with no orientation that means anything at all. The arrows we drew on our childhood diagrams, the neat little arrow pointing up to sky and the arrow pointing down to core, have completely disappeared. They have not been hidden. They have not been overcome. They have been revealed for what they always were: local, provincial, dependent on standing on a surface, dependent on having feet, dependent on the small, particular fact that you grew up on the outside of a planet, with gravity pulling you toward its center, defining one direction as down and its opposite as up. Step away from the planet and the words simply lose their meaning. There is no up. There is no down. There is no above. Let those three short sentences sit, because they are, in the deepest possible sense, the truth our entire long journey has been circling. Above and below are not properties of the universe. They are properties of being a creature with feet on a surface in a gravitational field. They are grammar, not geometry. They are habit, not law. They are how we orient ourselves, locally, in the only place we have ever lived. They are real in the sense that they describe something true about our experience, but they are not real in any larger cosmic sense at all. The universe does not have an above. The universe does not have a below. The universe simply is. And we, small creatures briefly conscious, have been drawing arrows on it for as long as we have been able to draw anything at all. Look back at the line we have traced, the line that began at the top of your head and rose through every layer of the atmosphere into the long, thin slice of human-occupied space, across the gap to the moon, onto the sun, outward to the heliopause, past the Voyagers, past Proxima Centauri, into the Orion Arm, into the Milky Way, on to Andromeda, into the local group, into Laniakea, into the cosmic web, to the edge of what we can see, and possibly beyond into infinities we will never reach. And the line that fell in the opposite direction from the soles of your feet, through the crust, through the mantle, through the outer core, through the inner core, through the innermost inner core, out the other side of the planet, into the cold, deep ocean at your antipode, and onward into the sky on the far side of the world, and outward again into the very same universe. Both lines, in the end, point into the same vast openness. The line up does not end. The line down does not end either, except by passing through a planet and continuing as another line up on the other side. They are not two different journeys. They are the same journey, drawn in two directions on a tiny sphere, both of them eventually dissolving into the same boundless dark. What we have actually been doing, all these long hours, is not climbing a vertical ladder. We have been opening, slowly, gently, in every direction, from the surface of a small island in the cosmos. We have been learning that this island has thin air around it, layered like the skins of an onion. That it has a deep interior, layered like the rooms of an ancient house, that it lives in a wider sea of orbits and stars and galaxies and superclusters and cosmic web, and that we, briefly, are conscious things inside it, capable of holding the entire architecture in a single fragile mind for a few quiet hours of an evening. Remember the picture we began with, the simple childhood diagram. The round blue ball with the arrow pointing up to sky and the arrow pointing down to core. The neat cartoon, the tidy little world. It is not wrong exactly. It is simply the smallest, most local, most modest description of where we are. It is what you can draw with two arrows. The reality is what we have spent all these hours together trying to gesture toward. The reality is layered. The reality is vast. The reality is ultimately beyond any single picture. And yet here you are, lying still, listening, holding it. That is no small thing. That is, in fact, perhaps the most remarkable fact of all. That a small wet creature on the outer surface of a small round planet can, by quietly closing its eyes, take an imaginary line straight up from its scalp and straight down from its feet, and trace it across the layers of an entire universe. The universe does not care about above and below, but the universe somehow has produced a creature that does, and that creature is you. I want to ask you finally, very gently, after this long evening of climbing and descending and dissolving, what stays with you? Not what you remember, not what you can recite, but what feeling lingers? Is it the staggering thinness of the breathable air? Is it the strange beauty of noctilucent clouds glowing long after sunset, 80 kilometers above your head? Is it the steady, faithful loneliness of the voyagers, still whispering home from beyond the heliopause? Is it the ancient solid heart of the planet, growing patiently outward at a millimeter a year, while you sleep? Is it the dark stretch of antipodal ocean, mirroring you across 6,000 kilometers of layered stone? Is it the cosmic web, the great filaments and voids, the immeasurable heaven of Laniakea, the possibility that beyond what we can see, there is more, and more and more, possibly forever? Is it the simple, beautiful fact that above and below are not real and that you have known that somewhere inside all along? I would love to know what stays with you, which image, which moment, which scale. Tell me, if you wish, in some quiet line at the end of this. It would mean something to know what your evening has held. Before I let you go, gently, if any of this has reached you, if any of this has stilled you, if any of this has given you the slow, soft awe that long journeys through quiet ideas can sometimes offer, a final small favor. A quiet like, a soft subscribe, a few quiet words below this voice. Each of those things makes it possible for more journeys like this to be made, for more nights like this to be offered, for more small creatures, lying still in the dark on the surface of small round planets, to be reminded every now and then of the layered architecture they live inside. That is the last time I will ask, and from here, the rest of the evening is yours. So let us close slowly. The line above your head does not end. The line below your feet does not end either. The moon is drifting outward by a fingernail's width each year. The sun is burning. The voyagers are still whispering. The galaxy is turning. Andromeda is falling toward us, patient and inevitable, over the next 4 billion years. Laniakea is flowing toward its great attractor. The cosmic web stretches out around you, in every direction, indifferent to which way your feet are pointing tonight. And beneath you the molten ocean swirls, and the heart of the planet beats its slow, ancient beat, and the innermost inner core remembers in its quiet, crystalline way an event from long before any human being walked the earth. All of this, right now, all around you. Above, below, beside, beyond. Words that no longer quite fit. A geometry that has dissolved into something gentler. A simple, breathtaking truth. You are a small conscious creature inside an immensity, and the immensity in some quiet way is now also inside you. You will close your eyes tonight on the surface of a small round island. You will sleep. The earth core will spin its slow, breathing rotation. The cosmic web will extend itself patiently across the dark between galaxies, and you briefly gently will rest somewhere on the thin, warm skin of all of it, held by gravity, held by atmosphere, held by the layered architecture of a world that has been beneath you and above you and around you every single moment of your life, without ever once needing your attention to keep doing what it does. There is no above. There is no below. There is only the immensity, and you, inside it, sleep well under the stars, and underneath them too, and beside them on every side of you in every direction at once. Good night.